it says consider the following P of X. And then it tells you that C equals negative 1, 3. And it's asking you to show that those are zeros of P of X. There's two ways of doing this, okay? However, in regards to this, because at the end of the question they ask you, okay, now what are the other two zeros? Because it's a fourth degree polynomial, right? So it's going to have 4 zeros, okay? Now, there's debate and there's discussion of whether those zeros are going to be real or not real at some point. I think all of these and this one are real zeros, meaning they are on the x-axis. Okay, so there's no I involved in them, which could happen. Two ways of doing it. One says it was what we called the remainder theorem. Okay, and ultimately it meant that if I plug in this C value of negative 1, so P of negative 1 is equal to 2 times negative 1 to the fourth, minus 13 times negative 1 to the third, plus 7 times negative 1 squared, plus 37 times negative 1, plus then 15. And evaluate that, okay, so it's going to give me 2, this will be plus 13, plus then 7, minus 37, plus 15. Okay. When I do that, okay, this should equate to 0, right? Okay, 2 plus 13 is 15. 15 plus 7 is 22. Plus another 15 is 37. So I got negative 37, positive 37. That equates to 0. Okay, so the remainder theorem says that P of C is going to be equal to your remainder. Spell it right. When you kind of plug that value in, okay, and we do our division. Now, if my remainder is 0, it tells me that essentially x plus 1 was a divisor of that polynomial. Does that make sense, everybody? Okay, that's kind of what that's what I talked about in that video yesterday in regards to the remainder theorem and the benefit of it. Now, that just shows that that was indeed a 0. Negative 1 is a 0, good to go. Okay, we'll do the same thing with 3 and find out that that's going to give me 0. But that doesn't benefit us in regards to the second part of this question. Because the second part of this question says find the remaining zeros. Well, that means that I would have to be able to look at C equals negative 1 and C equals 3 and somehow show that that is going to kind of depreciate this polynomial. All right, so this is the way I would do it, guys. And you can do long division if you prefer long division, but I prefer synthetic division because it's quicker. All right, so my C value is the value that goes in the box. So negative 1, and then I'm going to write my coefficients of my P of X to negative 13, 7, 37, and 15. Now, I just be cautious, make sure that I don't have any missing variable terms, right? So if we skipped like x squared, we'd have to put a 0 in here. If we don't put our placeholders in, it's going to just mess everything up for us. Okay. The benefit of synthetic division is that it's quicker. Okay. It's going to get us to our depreciated function so much quicker. But the payoff or the cost of that, I guess, is that we lose notation. Right. We have to remember what this really means to us. This phrase right here is saying the exact same thing that thing up there says. Okay, we're just not doing it. We're just not paying attention to the variables. All right, so synthetic division then was to bring the 2 down, bring your first coefficient down. Okay, and ultimately, guys, because this parallels to long division, because if you think about long division, there'd be an x here, right? Okay. And it would actually be x plus 1, but this would be 2x to the fourth. And we'd be asking ourselves, okay, what do I need to put on the top here of my division so when I multiply by x, I get 2x to the fourth? Well, doesn't the coefficient have to be 2? Does that make sense? Okay? It's always going to be whatever that coefficient is. And then however many variables I need, so it'd be x to the third, which is something we'll talk about when we get done here. But that's why we always drop that 2 down. Okay? Now, every other step is taking essentially that quotient up top and multiplying it by your divisor and just then aligning it with the other terms of your dividend. Okay? So this is the exact same thing as long division. All right? And the process, or it's called an algorithm. It's a step-by-step process that we go through to get this, is long division. Okay? Just, again, we lost notation, so maybe we don't see directly the fact that we're doing the same thing we do when we do long division. So now the next is, what is this? This is negative 1, sorry. All right, so now we take the negative 1, multiply it by that, and then we transfer that number right here, and now we add straight down. So it gives me negative 15. Take my negative 1 times the negative 15. That transfers up here, positive 15. So there's a 22. Multiply negative 1 times 22. That transfers to there. So that gives me now 15. Multiply gives me negative 15. And there is proof then, because that last column there is my remainder. Does that make sense? Okay. So there is my remainder of 0. That's the exact same thing I found by evaluating p of x at negative 1. All right. Now, why is that beneficial? Because now, what that effectively tells me, if this was x to the 4th, this here is x cubed. Does that make sense? Because when we divided by x minus a negative 1 would be the factor here. If you divide a polynomial by a linear factor, it's going to depreciate it by 1 degree. Okay? So what this means to us is now p of x is actually the same thing as x plus 1, x minus the negative 1, and now times 2x cubed minus 15x squared plus 22x plus 15. All right, so I just start with x cubed. This becomes x squared, x to the first, and now my new constant. Does that make sense, everybody? All right, and just to check that real quick, we could go to some solver. I'm sure, Brenton, you found enough of these online, these calculators online, haven't you? Cheater. But it's not a bad idea, guys, to find those, as long as you're using them appropriately. Okay, so I just have to write expand out in front of it so it does it correctly, but that gives me 2x to the 4th minus 13x cubed plus 7x squared plus 37x plus 15, right? Exactly what we started with. So it just shows me that I have an alternative form. Well, what is nice about that? Look at this. It depreciated my polynomial by 1 degree, right? Now I've got a cubic in those parentheses, which is easier to factor than a quartic, right? However, cubics are still difficult, but they tell me that this thing, this 3, is yet another factor. Okay, so it's kind of dependent on how your kind of organization skills on how you do these. I usually just rewrite the depreciated polynomial. That's what I'm calling this, the depreciated, because it's broken down, right? It's lesser degree than what we started with. But they say 3 is also a 0, or we want to check that 3 is also a 0. So basically all I do is see if that divides that thing. Okay, and the logic of this is, think about like the number 30. Okay, and I asked you, is 30 divisible by 2? And is 30 divisible by 5? Okay, well, if it's divisible by 5 and or 2, then it should be divisible, and it doesn't matter the order that I divide it. Does that make sense? So if I divide by 2 first, and then ask, okay, is that thing divisible by 5 then? Is 15 divisible by 5? Absolutely. So being able to say, yes, 15 is divisible by 5 is saying the same thing that 30 was divisible by 5. Okay? Meaning that it didn't matter the order. Because now if I ask you, is 30 divisible by 5? Yes. And now is 6 divisible by the 2 that I started with? Yes, it is, right? Does that kind of make sense? Because 30 is equal to prime factorization, was it 3 times 2 times 5? Does that make sense? And because the commutative property, it doesn't matter the order of the 3, 2, and 5. Okay? So through division, it doesn't matter whether I divided by -1 first or I divided by 3 first. Does that make sense? And then it also does not matter whether, I could go back and I can plug that 3 with the original p of x, okay? The 2x to the 4th minus 13, x cubed plus 7x squared plus 37x plus 15, and divide that by a 3 out the box. It'll give me an appreciated polynomial, but it's going to be a linear term, x minus 3, times now a cubic again, okay? But what I'm doing now is the idea that instead of dividing 30 by 2, it's saying, yeah, it works. And then saying 30 divided by 5, yeah, that works. Let's take 30 divided by 2, get that quotient. Now take that quotient divided by 5. Okay? So there's a lot of parallel kind of ideas that we've seen with just basic real numbers with what we can see here with these polynomials. I'll bring my 2 down. 2 times 3 is 6. Okay, it's going to give me, what, -9 here. So it gives me -27. So it gives me -5, -15, and now I get a 0, right? Now, what's nice about that is that tells me that p of x, the original p of x, okay? We had that x plus 1 from previous. We saw that divided. We now have this as a 0, so it gives me x minus 3 as a factor. Is that okay with everybody? And now this, remember, this was x cubed when we started this division by 3, right? Or x minus 3. So what's this term going to be? X squared, right? So 2x squared minus 9x minus 5. All right, so if I were to FOIL that out, which is not all that difficult of a task, but we use the GeoGebra or some other computer algebra system, it would show us that that is equivalent to 2x to the 4th minus 13x cubed plus 7x squared plus 37x plus 13. Now the question is, what are the other two zeros? Well, we just shown that 2 of our zeros came from that information there, right? So where are the other 2 going to come from? The other 2 have to come from that, right? So I'm going to... Now, we'll talk about some other techniques later on, but that's a quadratic, right? Do we have a series of rules or processes that allow us to factor something like that? I would use the AC method here, see if I get -10. Okay, so that'd be what? -10 and +1 will have to give me -9. So I'm going to rewrite this as 2x squared minus 10x plus 1x minus 5. Group the first 2, group the last 2, factor a 2x out of the front. That's going to leave me with x minus 5. Take a 1 out of the back. So that factors at 2x plus 1 and x minus 5. Okay? My hope is that we realize because of this, because of what could show up right there, and ultimately becomes that quadratic, that we fully understand all of our possible ways of factoring quadratics that we talked about like the second, third, fourth week of class. Okay? So now, this can replace that, right? So 2x plus 1 and x minus 5. If I were to multiply that out, it will get me back to the original p of x. Now, the in question of this was, what are the other 2 zeros? So we see the other 2 zeros are 5 and -1/2. When I take those red factors and set them equal to 0. Okay? So that is the process, guys. Now, it's obviously a lot longer, but that is the process for factoring polynomials of greater degrees other than quadratics, and some of the convenient, maybe 4th degree polynomials that are in quadratic form, or 3rd degree polynomials that all have an x in them or something like that. Okay? If we don't have a tool to factor, this is the route we go. Okay. Now, they kind of do some work for us. They set us off telling us that these were two factors here. If I didn't know that -1 and that 3 divided P of x to begin with, ultimately telling me x plus 1 and x minus 3 were factors, then it's going to be really hard for us to get down to that 2x squared minus 9x minus 5. Okay, so they're right now in this section, they're giving us information to start with. Okay, we will learn pretty soon how we can come up with those on our own. Okay, give me 1 second. I think this is question 14. You guys want to continue using synthetic divisions? Anybody prefer long division? Synthetic division's okay? I think that's the best route to go. So I'm going to write my 4, my -9, -50, -27, +10. Out in your box is always C, okay, which if you watch the video, sometimes they'll say x plus 2 is a factor. So what goes in the box? It's the solution to that equation, x plus 2 equals 0. So -2 would go out here. Basically telling us that what we're doing here in synthetic division is checking the 0, and the 0 is the answer to that equation. Okay, so bring down my 4, multiply gives me -8, add straight down gives me -17, multiply by 2 gives me, 34 here, add straight down gives me -16, multiply gives me 32, add straight down gives me 5, and now multiply gives me -10, which would be 0, right? Tell me that -2 is indeed a 0. So x plus 2, I'll just write it up here, x plus 2 is a factor, right? Okay, now this is what I was kind of talking about earlier with depending on how you organize your work, because I've got to keep going, because this was x to the 4th. This is now x to the 3rd, and I like to at least put that first variable in. I don't ever use it, but it just reminds me when I'm done what my kind of depreciated function looks like. Now I'm going to try 1/4. 1/4 up there. And now I'm just going to work here with this 4, bring it down. Multiply gives me 1. -16, when I add those together, 4 to 16 is 4. Be negative though. Excuse me, -20. 4 to -20 is -5. And I get 0 there. Is that all right, everybody? So that then tells me that x minus 1/4 is a factor. Okay. Also then, if this was x to the 4th, that became x third. What's this one going to be here? X squared. Okay. So right now I have P of x to be the product of x plus 2, that linear factor, x minus 1/4, that linear factor, but now 4x squared minus 16x minus 20, which that is a quadratic factor, right? Okay. Now we're going to get into eventually, it might not be today, it might not be tomorrow, but we're going to be getting down to what's called fundamental theorem of algebra, which is going to help us realize that every one of these polynomials could be written as a product of linear terms, okay, linear factors. So that 4x squared minus 16x minus 20, that can go down a little bit further. Okay, so let's come over to the side here. We have 4x squared minus 16x minus 20. What can I divide everything by here? It's 4, right? Now, this is just an expression. It's not an equation at the moment, right? So don't let that 4 disappear. Okay? So I'm just going to bring the 4 out like this. It gives me x squared minus 4x minus 5. And now that's going to factor to x minus 5, x plus 1. And I still got that 4 out there, right? Okay. So rewrite this thing as x minus 5, x plus 1, and then I like to put my 4 all the way out the front. Okay. And that then shows me that I had a 0 of negative 2, a 0 of 1, 4, a 0 of 5, and a 0 of negative 1. Okay? Now, every once in a while, I don't know how math excels, or sorry, not math, WebSign is going to grade this, because that's all products, right? It's all multiplication. Can that 4 be distributed to any one of those? So can I write that as 4x plus 8 times x minus 1, 4 times x minus 5 times x plus 1? Or could I write it as x plus 2 times 4x minus 1 times x minus 5 times x plus 1? You can take that 4 and you can apply it to any one of those other factors that you want if you see that useful to you, okay? I like to have all my factors that have a coefficient for the x term as a 1. So I try to factor all those out anyway. Does that make sense? Because then it's real easy to just look at it. You can do real quick mental math and say, okay, 0, negative 2, 0, 1, 4, 5, and negative 1. Okay? Where if I have this as like 4x plus 4 for that last factor, I got to do a little bit of work there to find that 0, right? It's not just a visual cue. So I like to pull all those coefficients out and making my x's to have coefficients of 1. All right? Okay, so today then, guys, that's going to kind of